Good afternoon, everyone. Hopefully, you're in the afternoon of your day. This is Bobby Harris, the Executive Director of the Utility Broadband Alliance. It's my pleasure to welcome you all here to our webinar today. We are going to have some in-depth and very important discussions around cybersecurity. And clearly, you didn't come to talk to me. I want to remind everyone, as you're getting logged in, to utilize the questions tool on your toolpad. If you have questions for the speakers today, we will try to save some time at the end, and we'll get to as many of those questions as we're able to. Please remember that I'll read them verbatim, so type them like you want them read. And if we don't get to your question, of course, we'll follow up with you after the webinar one-on-one from our speakers. So no need to worry about that. Also, I'll remind you again at the end, if any of you are not registered yet for the Utility Broadband Alliance Summit and Plugfest in November, that'll be the first week of November in Charlotte, North Carolina, where Duke Energy will be our host utility. And you can go to ubbaplugfest.org and you can see the agenda. It's being built out. We've got great sponsors, great speakers. The price is still really low, so you can just register online and book your hotel room. Okay, it looks like we've got most of the attendees logged in fairly fast here on the tool. And without further ado, I'm going to turn it over first to Ken Kaminsky from Ericsson to drive our content through, and then we'll go straight in with Spencer Burks from LCRA, and that'll give you the utility perspective on all this great technology. Ken, sir, I turn it to you.
Excellent. Thank you, Bobby. So my name's Ken Kaminsky. I'm a Director of Cybersecurity for Ericsson for their regional carriers and U.S. federal business. And for this talk today, we wanted to do something a little bit deeper, to go into some more advanced security controls in particular, because we've had quite a bit of sessions where we talk about a lot of the basic cybersecurity controls and kind of the stuff that's built into the network itself. And today we're going to kind of move a little bit more into that conversation, especially in light of a lot of the stuff that's occurred. You know, there's a lot of attacks on telecom systems networks that have been in the news. You have like Salt Typhoon, where some Chinese bad actors got into a lot of the larger telecom networks within the US. You have the attack on SK Telecom in South Korea, where a bad actor got in and compromised, a good portion of the network. And then we've had, portions of some attacks historically, like Kyivstar and Vodafone Portugal, where portions of the network were brought down completely by bad actors. So we're going to kind of go a little bit more onto the advanced side for this chat today. And where I'd like to begin is just, where we think about in terms of a security framework nowadays. And it's something called zero trust architecture. And this is a movement in thought in terms of just how we build security into networks from the older way of doing things, where we used to think more in terms of like a castle and a moat. So all of our defenses would be like the castle wall or the moat. Maybe they'd be like next-gen firewalls or systems like that. And those days are pretty much over now. We think in terms of zero trust, where zero trust is a way of thinking about security where you assume that the attacker is already inside your network and moving around. So we're not just talking about perimeter defenses, but we have to think about defenses that are not only there, but internal to the network itself. And some of the main ideas with zero trust are things like, we're going to encrypt everything. So all the data as it's moving and the data as it's stationary, all of that will be encrypted. we'll think about in terms of authenticating and authorizing not only every device that connects to the network and every user, but you think in Zero Trust about authenticating and authorizing every single flow, whether that's a human user or whether those are machine-to-machine connections that are taking place. You also think about segmenting the network. So we're going to build segmentation where portions of the network cannot talk to one another. So we'll segment off the management network from the control network and the user network and things like that. And then we're also going to build into the network things like continuous monitoring, logging, and alerting. This is a really important concept. So we're taking all of our logs and telemetry information from various pieces of the cellular network, and we're sending that over to systems that can actually monitor those on a continuous basis, and then are running different behavioral and rule-based programs there to see when an attacker is actually within the network itself. So those are some kind of larger concepts with Zero Trust. There's an organization also called ATIS, which stands for the Alliance for Telecommunications Industry Solutions. And ATIS is a standards body of North American telecommunication companies and manufacturers that comes up with standards that are, North American centric. So in the cellular world, we have 3GPP, which is a global organization, and we have ATIS, which is North American. And ATIS has come up with a bunch of critical security groups or security control groups for Zero Trust, specifically in a cellular network. And there's 12 of these controls, and a lot of them are embedded within the actual telecommunications infrastructure itself. So things like, data encryption protocols, encrypting data as it's in transit, how to do proper identity controls, how to segment the network. Things like this are things that are embedded within the telecommunications gear itself as it's implemented within the network. And then others, these things like continuous monitoring, threat detection and endpoint detection and response. I'll talk about this as we go through it. And then things like AI, machine learning, detection for anomalous behavior. These are things that are implemented with cybersecurity controls that are built into the existing network. And they live in that world where the telecommunications network components come together with all these existing cybersecurity tools that are out there, and then these two worlds have to meld together. When CISA, which stands for the Cybersecurity Infrastructure Security Agency, this is the primary agency of the United States government that is has been detailed to take care of critical infrastructure within the United States, and telecommunications falls within this. When that Salt Typhoon attack by the Chinese came out, they came out with some recommendations as they analyzed that attack. And they were, to basically strengthen visibility within your networks. This is that area in particular of continuous monitoring that I mentioned. To secure your network by design, to harden your systems and your devices. And they had some very specific guidance for Cisco in particular, because Cisco is one of the main router and switch vendors that's out there. And I'm going to what I'm going to do here now is I'm going to focus in on a couple of areas of this. So in particular, in the strengthening visibility and the hardening of systems and devices here. So I'm going to talk about something called a Telco Security Manager, chat a little bit about vendor hardening guides, and then talk about the endpoint detection and response agents here. So one thing just in terms of hardening your network, All the vendors like Ericsson and the other vendors like Nokia that are out there, we all have these guides that we put out to harden our network gear. And this is something that you'll want to become quite familiar with. These are node hardening guideline documents, and there are generally documents for every single piece of gear that we will go ahead and deploy within the network. So everything has a hardening guide, and they include things like they're very detailed documents. They include things like, this is just an example for like a signaling controller on the signaling side of the network. This is an example, from our side of the house. There's sections on network security that have all of the various ports that'll be open, network policy, filtering components there. There's sections on like identity and access management, sections on pre-hardening the system components, and then on end user security. And I just bring this up to recommend that you become very familiar with these documents. The vendors will use them when they implement these networks, and they're really good references to understand. When you're talking about a continuous monitoring architecture in a cellular security environment, there's a number of components that come into play here, and I'm going to focus on these individually as I go through this. So I'm going to pop this slide up as I go through the presentation. First section here, I want to concentrate on this area here, where we're talking about logs and telemetry information that are flowing from the radio network, and then also from the core here over on the right. And when you're talking about this type of environment in a regular enterprise network, you have these systems to the upper right. And the main one here that I want to focus in on is this thing called the Security Information Event Management System. And these things are designed to take logs and telemetry information from a regular network. So like all of your routers and switches in a regular network, all of your servers and applications and your endpoints will send logs to this. And there are vendors out there in this space like Cisco Splunk, Sentinel, IBM's QRadar, that are designed to process, those logs and telemetry, and they run rule sets on it, and they'll tell you when you have a bad actor that's entered your network because it's processing all of this data. And that works great in the enterprise world, and these systems were really developed in the IT space. And the main issue that I want to bring up here for this audience is that there are use cases in the telco world that are not covered by those systems, and you need to figure out a way to cover them when you bring a telco environment into an enterprise space like we're doing when we're building these networks for large-scale utilities. And in order to meet these use cases that were not meant by those vendors because they were primarily IT-centric, the telco vendors have come up with these products, and I've just called it a generic telco security manager product. And we had to come up with these because there are use cases that are out there that just aren't there out of the box for those security information event management vendors. So the way that it works is you'd pop potentially one of these into your network. It would handle those use cases, and then it would report up to that existing vendor that you have there in your network, all of the notifications and the attacks that it's seeing, so that your incident responders could continue to work from your existing SEM vendor that's here. And when you're looking at what those use cases are, I generally fall into these categories here. So there's attack surface management, And this is a baseline automation of security configurations that are out there. So the way this use case works is you have security configurations for all of these deployed radio access network core, functions that are out there, and you have all these different configurations. And this type of a use case will basically allow you to configure those. And then if for any reason that configuration got changed for whatever reason, maybe it was a good reason, like maybe some emergency change, this type of a system will automatically be always auditing those devices. And if it got changed, it will configure it back automatically. So it's meant to automate things that we've had to do from a manual perspective in these networks prior. It will do that particular function. We call this OAM, or Management Network Threat Detection. This is that feature here that I just chatted about, where it's actually reporting all of these logs and telemetry. This particular device is processing those and then reporting it up to the SIEM. Another one is these endpoint detection and response agents. I'll explain those in a moment. And then the last one is detecting false base stations that might be out there, or maybe some jamming device that's out there within the utility spectrum. This will actually go ahead and figure that out. Now, when we're talking about this function here, so we're looking at all of these logs and telemetry, and we're looking for bad actors by this telco security manager. You have the option to either develop it yourself or purchase it from the telco vendor that you've bought the network from. If you did decide to do it yourself, you would actually have to know quite a bit about that telco vendor's logging formats, their telemetry information. And then your own engineers on maybe your Cisco Splunk or your IBM QRadar would then have to write all of the rules that correlate all of that information together. And that's possible, but there's quite a bit of an effort that goes with it. And those are really your two choices with this OAM threat detection use case. You can either have your own engineers do it, or you could just purchase the use case from the telco security vendor of your choice. So those are your two options with that use case. On endpoint detection and response agents, this is another use case that could be potentially provided by this type of a vendor. Now, just a second here, I'm going to what is an endpoint detection and response, or an EDR agent? And these agents are deployed all across your existing enterprise. Most enterprises have them deployed on every single laptop and desktop within your particular enterprise. They're often deployed on every server and application, often that's running there. And they're deployed all over the network in order to act as basically a security grid. And these are very advanced pieces of software that look at the behavior of what's going on that endpoint in order to figure out if you have a bad attacker or an attacker that's got onto your network. And then once they're on, there's a lot of capability to forensically detect this stuff and then keep that information there, and then report up to a management station that can tell you when an advanced attacker gets onto your network. These EDR agents are an absolute requirement for cyber security insurance, for instance. You can't even get insurance without these endpoints being deployed across your infrastructure. So these are pretty mandatory in the enterprise world. And when you're looking at deploying these in the cellular security environment, you really have two options to do. You could buy them from a commercial vendor that's out there, like someone like a CrowdStrike or a Palo Alto or some of the other vendors there. And then it's the same type of a trade-off here. You have to have your folks that would know how to write those rule sets, which can become quite advanced there. And then you want to work out any issues with loading those agents up on the telco vendor's environment and within their software. So you could actually do it that way, or you could just purchase it from the telco vendor and use their EDR agent solution, whether that's something that they've built themselves, or they have their own commercial agent that they've built into their existing infrastructure. And this can be difficult, by the way, to do because these environments can be pretty complex in the telco world. So number one, it's all Linux based. Number two, it's running on Linux containers. So it has to operate in that Linux container environment where usually portions of these agents are running up in the container where the application's running, and then down in the operating system in order to get a really good view as to what's going on that endpoint. There's also very specific protocols that exist just in the cellular environment. We have very specific protocols in the signaling world, like SCTP and PFCP. And we have very specific tunneling protocols that we run, like GTP. We have very specific roaming signaling protocols that run. So the engineers that write these rule sets have to have a good understanding of all that. And then you've got to have a good understanding also of the existing Linux security functions that your vendor has built into these products. And there's all sorts of different security kind of a functionality that's unique in Linux, like SE Linux App Armor, vendor-specific hardening that's been built into it. So if you're writing rules for this, you've got to be able to understand how the vendor built those. So those are really the two options you have. You could build them yourself, with all of that, complexity that's there, or you could just purchase it from the existing telco vendor that you are buying the network from. So option one, option two, either one of them you can do, and that will give you an EDR agent grid. And at the end of the day, you'll want them to be, included in your management systems that you're using within your core network here. And like I said, there are pieces of this that exist in the container up here and then down here under the underlying operating system, because these are looking in a very advanced way as to every action that's happening on the endpoint, looking for an attacker that's actually got into that. And then over here, in your RAN baseband area here, and this gets into, I had mentioned that Cisco specific area there that CISA had mentioned earlier. These things like routers and RAN basebands are really just Linux environments also that are highly structured and engineered by the telco security vendor, where the telco security vendor adds, for instance, silicon that's related specifically to the cellular network there, and then they engineer these things to be really an appliance. And that's really what a RAN radio access network baseband is. And the vendors that are out there, you can ask them, they've often integrated an integrated EDR agent into this environment. So not only could you have EDR agents across these network functions over here to the right, but the vendors that are out there are integrating them also into things like the RAN basebands and the routers, so you can have a complete EDR grid across your cellular network. Other things that these systems do are looking for things like false base stations. So you have the ability here of these types of telco security management platforms to find anyone that's standing up a false base station within the utility spectrum space. And you can do this by purchasing something like a software-defined radio. It costs a couple of $1,000s to do this. They can generally integrate into that some type of an open source environment from vendors like SRS and some of the others that are out there. And that becomes the software that's loaded up there. And then they can run up a false base station in order to try and attract endpoints to go ahead and connect to those. And the way that these types of systems actually work and detect that is 3GPP has implemented a number of standard features into all of the endpoints that are out there. And they do these things like automatic neighbor relation, ANR, or minimization of drive tests, MDT. And what these things do is the endpoint is always looking at the spectrum space. And it's looking at, who can I connect to in terms of base stations that are out there? And they're monitoring that and collecting statistics on that. And the way that these false base station detection environments work is they use that existing functionality that's built into all their endpoints, because those endpoints are talking to the network and telling it, this is what I'm seeing out here in all my spectrum space here. I see a base station here, and here's all the parameters that I'm seeing about it. And this type of software can actually process all of that, detect the false base stations that are out there, and then plot those on a map for the utility to be able to see if this type of activity is actually going on out there. So that's another use case that can be used here. Here's a couple of real world examples in the attacks that have taken place. So in the SK Telecom attack, it used some malware called BFP Door. And this is just a Linux malware version that's out there that's used by a lot of bad actors. If this gets onto your network, these telco security managers can detect that specific malware. It could detect oddities in the queries that are going around on the subscriber database. It could detect oddities that are going on the HSS, which is a front-end communication piece that's actually managing the subscriber database, and the various connections that are coming in terms of the security, some of the security pieces with that. And then it can also implement protective security controls over some of those functions that are there in order to prevent that. So this is just one example. Another example here is there was a recent attack out there called the Erlang SSH attack. And SSH is a terminal program that's used all across the telco infrastructure for secure access going in from a terminal perspective. And this attack could be picked up on the basebands themselves, the radio access basebands, because we would see that exploit attempt there, and those messages would be reported up. It would detect that, and then it could also implement additional security controls around protocols like SSH and some of the others that would use this in order to make a more secure configuration that would protect against that specific attack. So these are just two examples in order to show you, real world examples of how, these could specifically be mitigated by a telco security manager. Really quickly here, going back to this cellular, this continuous monitoring architecture. So I talked about this one here with all of the logs and telemetry being collected and how it would go to this telco security manager. I'm going to chat about this particular device down here. This is called a network detection and response. And there are various vendors that are out here like Cisco StealthWatch, Darktrace, and a number of others. These have existed in the IT security and the OT security space for quite some time. And they operate in a way that they process all of the information about the individual IP connections that are always going across the network. And they collect information about each IP flow. Things like the IP address, the source and destination port, all sorts of things from the headers, the application that might be flowing there. And the way that these vendors operate is they're doing two very important security functions. Number one, they'll tell you when you have odd or anomalous flows that are occurring across your network. So if you have someone that's there on your network and they're communicating externally, like out to the internet, like for a command and control type of connection, when a bad actor, gets on your network, they want to be talking to some, mothership that's out there. These types of things will flag one of those connections there because that stands out like a needle in a haystack. And they'll tell you when that's going on. They'll also tell you when you have weird communication patterns that are out of the ordinary. And these are really good things to be looking for from a security perspective. And then if your network has been attacked, it can actually give you a historical view into that. So if you know that your attack came from this point, it's got a complete record of all the connections that have occurred historically, and you can track that attacker all the way across your network infrastructure, where they've been and where they've connected to. So they're excellent in terms of figuring out attacks that are taking place, and then historically where that attacker has been. And what we recommend at Ericsson is that you look at your management network in particular, and you add the interfaces. These are just routed interfaces where you're going to send this information, which, by the way, is a protocol called IPFix. This is kind of the overall protocol that sends that information. These are from router interfaces, and you're going to send those over to these collectors, and then they report up to an NDR management station. So what we recommend is include your management plane into that, and then you'll have the ability of that particular technology from that vendor protecting your management network and giving you that capability. And then the last thing really quick that I'm going to talk about is the ability over here on the right. Sometimes people want to have full packet capture capability for all of these interfaces that are happening within the cellular core. And this full packet capture capability captures literally the full packet, the IP packet, and then it talks to vendors that are out there in your network like NetScout or Gigamon or some of the other ones that are there. And they want to be able to capture all of this information for security purposes. And the big thing that I want to point out here is that in a cellular network, these are all operating as Kubernetes containers. And in a containerized network, you could have one network function that's running here on one physical server, talking with another network function that's running on a different physical server. And those network functions could be within the same network function, and they could be they're not able to be tapped on just one IP interface like you could do in the old virtual machine world. In a Kubernetes world, these containers could be spinning up across multiple servers, and you've got to be able to get at those from a software capability function. And to do that, it's not as clean or easy as in the old virtual machine world, where you could just tap a virtual interface and you could see all that information. These network functions could be all across multiple different physical servers. And in that environment, you have to have some type of a software mechanism that can tap into that and then send those packets up to your NetScout or Gigamon devices and vendors that are out there. And what you've got to have is some type of a software probe solution that's able to do this. Basically build those packets and then send them over. So you want to ask your vendor about this if you want to be able to tap your core to have the ability to do these software probes. And with that, I'm going to turn it over to Spencer for the next section here. So Spencer, if you want to take it away from here, I'll move the slides when you want.
Okay. Hey, thank you, Ken, and thank you for inviting me here to UBBA, Bobby. Just to start, I lead LCRA's private LTE program, and I'll give it a quick introduction to LCRA, just who we are, talk a little bit about our network, how we deliver value, what the use cases are, and then I'll talk more on what Ken really did a great job of describing, which is some of these advanced cybersecurity capabilities that we have the advantage of using. So LCRA is a river authority. We manage over 800 miles of river and a whole chain of dams. Those dams are used to manage the region's water supply and also to help mitigate floods. We do operate what we call our hydromet network. It's a lot of sensors that we use that do real-time hydrological modeling to model when water hits the ground and how long until it hits what areas. If you read the news recently, you probably saw there was a lot of flooding in Texas back in July. And so it was definitely one of the networks that was really important and crucial for that response. We also have a generation business where we provide wholesale power services to local cooperatives and municipalities. We also operate a fleet of generation that provides reliable power into the ERCOT grid. Third, we have a transmission business. We're the second largest operator in ERCOT. We have over 5,000 miles of line across 80 counties and growing. And then finally, we do a lot of community services. Some of that is broadband, where we have leased fiber services to underserved areas. Our radio side, we operate 2 LMR networks today. One is for utilities and transit authorities, and the other one is for public safety. The one that is focused on utilities and other transit authorities in that business is actually what we are migrating to LTE today. And then finally, we have a lot of parks. There's a lot of ranches that LCRA purchased when building the Highland Lakes, and there's excess property that we make available to the public. Yep, next slide. So there's 3 pillars that we have with designing our network. And this is really how we deliver value to our customers, and our customers being those internal businesses, but also some of those external facing entities. I mentioned our municipality customers, our cooperative customers, other public service entities, public safety entities, and really that starts with reliability. So this is a dedicated network for critical infrastructure. It's designed to work when nothing else does. There's minimum design standards. For example, we have 7 days backup power at all of our sites. And that's everything, including transport. Everything is also segregated out, so it's not reliant on any sort of third-party infrastructure, so we can have full power outages and be an outage response and still be able to communicate. It's also about resiliency. Resiliency is about having really just air-gapped infrastructure from the public, from a cybersecurity perspective, and also we've heard a lot about today, and I'm going to talk about more in a second, be able to deploy some of these advanced cybersecurity capabilities to our networks. And then finally, it's built for Texas. So we have coverage everywhere we are, which in a lot of our rural areas is a major concern where we don't have public carrier alternatives. We're also able to prioritize our network for mission critical communications. So that's prioritizing mission critical traffic and also providing low latency support for those low latency applications. Next slide. So the four main use cases we have today for mission critical communication, it all starts with mission critical push to talk. As I mentioned before, we are migrating a lot of customers from our LMR network today to private LTE, so the MCPTT. We also maintain interoperability with our P25 network, so that allows our utility and first responders to be able to talk to each other when responding to some of those major events. We also support grid automation and modernization. So for distribution customers, we're going to offer support for SCADA, for distribution automation, for DER, all the sensors, all the grid protection relaying schemes that they're going to put in place on the distribution network that will be supported on our network. We also have a lot of smart meters in the neighborhood. And that's both on the electric side and on the water side, but we'll support behind the glass LTE for all those, as well as for collector stations, just depending upon what type of deployment a customer wants to do. And then finally, we support mobile data. So if you are a mobile utility worker and you're trying to respond to an outage and your AT&T service is down, you'll be able to use this network to do things like ticketing, work orders, be able to acknowledge when power has been restored to certain customers, then also just manage your fleet in general. So AVL and computer-aided dispatch as well. Next slide. All right, so getting into some of the specific features that we really employed and why. For us, it really started with core and RAN security. So when you're deploying a mission critical network, you're deploying a private LTE network at a utility, it's generally a new thing for your organization. One of the things that we're very fortunate to have is very advanced and sophisticated network engineers and cybersecurity teams. LCRA has a 24/7 cybersecurity operations center as well. The one thing that you don't have day one is a whole team to support and build out all these advanced alarming, to really get in and understand and have the skill sets and background that an entity such as an Ericsson would have or another OEM would have to be able to build out all those alarms and understand what's a real threat and what isn't. So one of the big advantages that you have as a private network operator is being able to take advantage of those resources that they have. And for us, that was the Ericsson security manager. So one example is looking at cloud native detection logic. If you're LCRA, one option that you have is you can go buy a third-party tool and try to integrate it with your mission-critical network and hope it works all the time and never has an issue. The other option is you can work with your own vendor. It comes as part of the software stack. You know that they've tested it as part of all their software updates, and you can really rely on it having that mission-critical performance. Some other things, getting to RAN detection logic. I thought Ken did a really good job of talking to how that works. I think a good perspective if you're a utility to keep in mind is because you operate endpoint devices, if there's a false base station going on, it's not just someone emulating your network. It actually is a denial of service attack if it's pulling your devices off your network so you can't communicate to them. Baseline automation, OEM detection logic, threat detection, all that, just being able to aggregate all the logs across all the applications, across all the hardware, being able to synthesize it to know what's really an anomaly, what isn't, what do I need to learn for, what isn't. This was a tool that made it really easy to just give us day one a lot of security feature and integrate it very easy and seamlessly with our SIM at our CSOC. So just day one, we had a very advanced cyber security capability. That was a big, perk for us. All right, next slide, Ken. So one of the other big things that we did in implementing our network that I think is a little different than if you're a carrier, for example, we really did network slicing in LTE. And so what that meant is full VRF separation between networks, not just within our LTE network, but also on our network edge. So from the point at which you have a data application that connects into your network, everything is on a separate VRF and is on a separate network slice. We implement a security gateway, so everything's encrypted across our transport as well. And when we segregate, that's not just between LCRA and another customer, that's even within LCRA, between business units, between networks. So if you have a generation network, if you have a water network, our hydromet network that I talked about before, if you have a transmission network, we're doing a lot of advanced metering or SCADA, These are all separated networks, and there's no ability for anything to talk across any of that. And as we add in third-party customers, we implement the same security standards there as well. There's no traffic coming across a internet connection, ISP connection. If we can avoid it, everything's private transport to a data center, private transport to a control center, and we're able to control it just from end to end. Next slide. And the other big thing, as I mentioned before, as a utility, you're not just operating the LTE network itself, you're really looking at end-to-end solutions. So one of the big gaps that you potentially have is your device security. But one of the big advantages of having a private LTE network is now you can get access to advanced data and information on your LTE core that can help provide security for those devices themselves. For us, there's a lot of automatic device baselining and fingerprinting. So if it's a recloser or if it's a smart meter, there's a certain behavior pattern on how you expect it to behave. There's also only certain devices which you're expecting that device to be on your network. And so you're able to actually identify, fingerprint, and alarm. And if you want to even do policy enforcement on that device to make sure you don't have someone trying to gain access into your critical infrastructure systems. We are using OneLayer. That's just who we've selected to help do that. That taps to our LTE core. We have physical taps. We also have the virtual probes. And so all that's needed to be able to aggregate the information and to properly handle device security. And there's a lot of capabilities that come with that. All right, next slide. All right, so that was really just a highlight of what LCRA has decided to do and some of the reasons why. Bobby, were there any questions from the chat?
Let's see. Remember, everyone, if you have any questions for Ken and Spencer, to go ahead and type those into your question tool, and we'll read them exactly as you write them. I don't see one coming in just yet, but that's usually because people are a little bashful as we're getting started. Oh, I thought someone was typing. Maybe. We'll give it a moment. I would say let's probably just continue the conversation while our audience is deciding what great questions they have for the two of you. I suppose, maybe perhaps talk a little bit about what you see the future with your LTE network and there at LCRA, Spencer, and maybe some use case you're thinking about going forward. If I can put you on the spot there.
Yeah, sure. So the big one we're working on right now is we're working to select a mission critical push to talk vendor, as I mentioned before too. So we're really excited about being able to give that LMR voice capability and not just looking at mission critical push to talk, but also looking at mission critical data and potentially mission critical video, especially in key locations such as power plants where we may be able to deploy some higher frequencies, have more data capacity. Part of that's going to be implementing a broadcast data core as well for the wide area network for MCPTT. So I know Southern's tested before. I know AT&T is looking at it, but it's just a really interesting technology that for us, given our site density and the call density that we have in some of our areas, to be able to make this use case work on private LTE. So we're really excited about what all features that's going to bring in and really modernizing something that, it's these old push to talk radios. They have the buttons that you turn, and there's a lot of people in the workforce now that don't really know how that technology works, and they're used to certain smartphone form factors and it isn't necessarily intuitive to them. So I think we're moving in the right direction just as a utility, and also being able to start consolidating systems. So it's not just your data traffic, but also your voice traffic as well.
Excellent. And I knew we would wait long enough and get some great questions in here. So I'm going to read them just as they're written. And for those of you, we've got about 10 minutes left. So we'll try to get to all of them. And if we don't, we will follow up with you. One question I can answer, someone asked about the recording and slides for today. We are recording and it'll be on ubba.com later, probably tomorrow. So Ken, I think I'm going to point this first question back to you. The ATIS control standards, Is that what the architectures that were shared today are based off of?
They're intimately related to the ADIS control. So ADIS stepped in because 3GPP, from a zero trust architecture standpoint, was primarily only focused on the core. And they built a lot of that functionality into like the 5G standards and things like that, but they were really just looking at the core side of the equation. So ADIS stepped in order to fill those gaps and define what all of those security controls should actually look like. And like in particular, I was really highlighting continuous monitoring. That continuous monitoring is a function that's absolutely required. It's called out in the ADIS controls. And in order to do it in a cellular environment, you either have those two choices. Either you write all that stuff yourself, with your existing security information event management vendor, or you implement like the telco security vendors' use cases in order to do that. And one of the major things I really wanted to point out today is that those telco security manager use cases, they're really critical to understand and to implement. And a lot of times I noticed, as utilities were rolling this out, that was an afterthought conversation. And what I would really encourage the utilities to do is to, especially if you're doing a new implementation, is to remember that it's a really required function. Remember, how you're going to do that as you're building out like your RFP and things like that, because normally the money for funding is available right in the beginning there. And you don't want to forget that particular function there, because it really is critically important to the overall cybersecurity of the network.
Excellent. Thank you. I think this one may follow on, although it's from a completely different person. Because as you were talking there, I was thinking of this same question, Ken. What type of people resources are required to monitor the outputs of these kinds of management tools? Again, as you're thinking through that cybersecurity question.
Yeah, it's a good question. And the reality is as utilities, you already have those systems deployed. Like you already have a security information event management system. You've deployed it already. You have some people that know how to do that. You have endpoint detection and response technology already deployed, in different places. The main thing here is, how do I bring those together with this telco environment that I've put in there? And melding those two worlds together, those original worlds in the security information event management, the EDR technology, that I talked about, that all developed in the IT world. And now we have to bring it over into the telco world. And you have people that can already do that in the IT space. They know how to implement those systems. They know how to build those rules, but they don't know how to do it for these telco use cases. And therein lies the rub. It's like, okay, I need to do it. So either I'm going to do it, or I'm going to have to, buy it from the telco vendor, from the telco vendor.
Yeah. And one thing I'll add to that, Bobby, just from LCRA's point of view, we like I said before, we have a cybersecurity operations center. They do 24/7 monitoring. They have a SIM that we use, Splunk, like Ken had mentioned. The alarms coming off the SM, it hits a Splunk border. It's all integrated in, so it's alarms on the dashboard at that monitoring center. Those alarms give you just a simplified snapshot of the anomaly. It's not, all the aggregation of the multiple syslogs coming together to be able to identify something that's already happened. So from there, it's you really have a lot of the skill set existing today just to monitor at that point. A lot of it becomes operational. So, you have to figure out, okay, well, what's our operational procedures? How are we going to respond to this? We're going to dispatch public safety. Is there a chain of custody question? do I need to call Ericsson to understand what this means? Do I need to triangulate this with another tool that I have? So there's some of that stuff. But a lot of what we're doing is we just internal experts. We have an architect, we have an operations specialist, and we've been focused on getting them skilled up, getting them more familiar with all the LT technology, all the 3GPP standards, doing a lot of the training that's available from your vendor just to skill them up so that they can be in a position to really respond to this and manage this. So that's a very different thing than if we had to really go hire someone external who understands the LT core well enough to really build a lot of this from scratch. So it really changes that profile.
That's a really good point, Spencer. Thank you. We'll get another question in. We've got a few more minutes. I think, Ken, this one's to you. If one goes with application layer security between microservices in order to get to truly zero trust architecture, then is there any aspect of the network layer security that one could relax?
Yeah, that's a very interesting question. The answer to that is no. You really can't relax those pieces. What the application layer does is, let's say I have a recloser, right? That's a device there. And zero trust demands that I am authenticating and encrypting information at the device layer and at the application layer. So at the device layer, that's going to be done with the network security functions that we've built into the network. So that has to be done. But if I'm going to do zero trust, now I need to do that for all of those application connections too. And that's going to be your recloser vendor is going to be the one that's going to do that. So in the recloser, they're going to have probably TLS will be the encryption mechanism. And you're going to basically, that recloser will talk to some type of an application up there in the data center. And those flows will be individually authenticated, authorized, and encrypted. And that's going to happen there at the application layer. And that's where you're getting microsegmentation in. So the real answer is you still got to do both of them in order to do zero trust. So that would be great if you could relax something, but in this particular case, you can't.
Yeah, I think I agree with you. Some reason we don't usually ever get to relax when we're talking about critical infrastructure cybersecurity, for sure. I'm going to pause there and ask you both final comments. We'll follow up with the other questions. I appreciate everyone. We'll follow up with you offline individually. But final comments before we close off for the day.
Mine would just be to reiterate, remember that the telco, this telco systems, they integrate with your existing cyber systems. And you've got to remember that in your security architecture. And that was a big part of what we wanted to, cover today. Just to remember that, don't forget it. Especially don't forget it when you get your big pile of money for the initial deployment, because it can be harder to get that later on.
That's a good point. Spencer, final comment from you, sir.
The big thing I'll say is when you're designing and building it and your private LT network, there's a lot of features that have really been developed that are available that maybe aren't mainstream used by the large carriers just because their business is different. And a lot of those features do enable you to have more advanced security, control, and reliability and resiliency. So I just really encourage anyone when they're building their network to really keep that in mind and keep that critical infrastructure deployment, those use cases in mind, and look for ways to customize the network to make sure you get the most out of it.
Excellent. Thank you. And my final comment is to remind everyone that they can meet both of you and hear more from you at the UBBA Summit and Plugfest in November in Charlotte, North Carolina. So go out to ubbaplugfest.org and register and book your hotel room so that you don't miss all the rest of the conversation, because we will be doing some serious deep dives on these topics in November. And I want to thank you on behalf of UBBA for taking the time to be part of this webinar today, to share your knowledge. That's what UBBA is all about, is collaboration, sharing knowledge for the advancement of utility critical infrastructure and telecommunications. Thank you both very much. Thank you to all who attended. Hope you have a great, safe, and wonderful rest of your day. Thanks, guys.
Thank you.